All right, so we are back to this section 5.3. Suppose a probability experiment is having two children. Construct the sample space. All right, well, we've done that before, but I'll remind you it's boy, 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 girl, girl, boy, girl, girl. Those are the four options for having children, right? And students always want to know, is there an order? Well, of course there's an order. You don't have children at the same time. Even if you're having twins, they're not born at the same time. So there's automatically a difference between boy, girl, and girl, boy. Just keep that in mind. All right. Event E is having at least one girl. List all the outcomes in E. All right. So when you have at least one girl, that could be boy, girl, could be girl, boy, or could be girl, girl. What is the probability of E? That would be 3 out of 4, right? Because probability of at least one girl would be equal to 3 out of 4, which would be equal to 0.75. Okay, cool. Now, what's the complement of E? All right, I want to be a little bit careful here. E complement, E, and I'm going to abbreviate it E prime, which is another common way to abbreviate complement, is not having at least one girl, right? Which must mean having boy, boy. That's the only option, right? Having 0 girls. All right? So that's kind of an important point, so make sure you follow. The complement of at least one is none. And the probability of E complement would be equal to the probability of boy, boy, which is 1 out of 4. Cool. So the complement of at least one of something, I just left the blank in for something, right? So, one of widgets or whatever is none, zip, zilch, nada, 0 widgets. So you can say widgets if you like. I just left it blank because it's not really a blank to be filled in. It's a blank standing for whatever, right? And the complement of that is the whatever. Okay? And it doesn't matter what it is. That's what I wrote down here. All right, so you go to a family reunion with your grandmother, and she introduces you to her cousin who has 12 children, all biological. What's the probability that they had at least one boy? All right, so this is where the whole at least 1, 0 kind of thing comes in handy. You don't want to figure out the probabilities for kids of 12 or families of 12 children. I mean, can you imagine? Boy, 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 girl, boy, 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 girl, boy, 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 right? It would be too hard to figure out. But you could find the probability of 0. Hold on, gotta bring it up. All right, so we want to find the probability of at least one boy. That's what they asked, right? At least one of something. So at least one boy. So we're going to find the probability of no boys. Oops, if I could do it right. No boys. All right. Hold on one second. Let me change my format. Okay, so that's 1 minus. All right, now I want the probability of no boys. But boys and girls are independent of each other, right? So what's the chances? Let me put it this way. Probability all girls. Right? If you have no boys, you have all girls. It's 1 minus. Okay, now what's the chances your first kid's a girl? 50-50, right? 1 out of 2. And the second kid, 50-50, and so on. How many times are you going to do it? 12. Right? So it's 0.5 times 0.5 times 0.5 times 0.5. Hold on. This is where Excel comes in handy. So I type equals 0.5 to the 12. And I can type equals 1 minus that number if I'm interested. That's 0.99976 equals 0.99976. By the way, my grandmother did take me to her cousin's house, and they did have 12 girls. So that's where that problem came from.